So today we'll be solving the problem number 3613, which is minimize maximum component. So let's see what we have given here. So before starting this problem, this I want to tell you that this problem was asked in the contest number 458 weekly contest, and this problem is very similar to the problem number 3608, and both problems are based on disjoint sets. And if you have solved this problem will be very easy for you. So in case you haven't solved this problem, so after solving this one, please try to solve this one, so it will be very good practice for you. So let's start. What is given to us? So you are given an undirected connected graph with n nodes. Okay, we have given a connected graph with n nodes labeled from 0 to n minus 1 and a 2D integer array ages. Okay, where ages will denote u, v and w, where denotes where ages denotes an undirected age between node u and v with weight w. Okay, so u and v will be telling us that there is an edge between the node u and v, and w will be the weight between both of the ages. Okay, the next thing given to us is an integer k. Nice. So you are allowed to remove any number of edges from the graph such that the resulting graph has at most k connected components. So guys, if you don't know what are connected components, I will tell you that highly recommend you that please try to search on YouTube, or I will put a video in the description as well, that what are connected components. You can go through that video first, then come here and try to solve this problem. Okay, so we have to keep the connected component count at most k. And okay, let's go to the next part. The cost of component is defined as the maximum age weight in that component. If a component has no edges, its cost is 0. Okay, so we will deeply understand this part. What does it mean? We will try run this code, this example, then we will deeply understand this. So what we have to return the minimum possible value of the maximum cost among all the components after such removals. Okay, nice. So we have given something like this with 5 edges, 5 nodes, some ages, and k is equal to 2. Let's try to try run it. So okay, I will quickly select my pen here. So n equal to 5, ages are 0, 1, 4, 1, 2, 3, 1, 3, 2, 3, 4, 6, and k is given to us as 2. Yes. So let's try to draw the graph for it quickly. 0 say 1, I am having 4 weight. 1 say 2, I am having 3 weight. 1 say 3, I am having, let's say, 2 weight. 3 say 4, I am having 6 weight. Okay, now what I have to do, I can remove any number of edges as I want, but the only condition which is given to me is the graph must have 2 connected component at most. Okay, so I can have 0 connected component, that will work fine. 0 connected, actually if you have given a graph, there will be at least 1 connected component. So 1 connected component can be fine, 2 connected component can be fine, but 3 will not be fine. Okay, so let's see what we can do. So what I have to, what is this line? Let's try to read it and understand it. What is given to us? The cost of a component is defined as maximum age weight in that component. So this is a component, right? I hope you can see this is a component. And what will be its cost? Try to guess. So they have given us, let's read it and understand. Cost of component is maximum age weight. It's very simple. Okay, so this, which one is maximum? This one is maximum, so this will be the cost of this component. Nice. So okay, that's if a component has no edges, its cost is 0. So if I have something like this, let's say 5, a single graph, a single node, so its cost will be 0. That's what written there. And the next thing given to us is return the minimum possible value of the maximum cost among all components after such removal. So what I have to do is, let's say I have some component here where the cost is, let's say 5, and if I have given something here cost equal to 7, so I have to return the minimum possible value, right? The return minimum possible value of the maximum cost among all components. So what I have to do, I have to return this 5 because this 5 is minimum among all the components. Let's say 5, 7, 9, whatever. So this component's cost is minimum, so I need to return this cost. So I hope you got you understood that what the problem is asking to us. Now let's try to solve it. So what we can do, we can remove as many edges as we want. So I have to do something optimally. I have to find the cost, minimum cost possible, minimum cost, right? So I have to minimize the cost. So what I can do, let's try to like think brute force approach, or how a human can do it. So I have some cost here, I have some cost here, some cost here, some cost here, and if I have to split it into two components, I can do lot of things. I can remove this part, so this will be one component and this will be one component. Yes, I can do it. I can do something like this also. So I will split out this two edges, so this will be one. Okay, I have to remove only, I have to make two components, right? So this will not work. I can remove this one, and this will be my another component. Okay, and either we, what I can do, I can remove this part, so this will be my separate component. So this will be component number 1, this will be component number 2. So I can do lot of things. So this one I can remove any of them, and my components count will be going to 2 from 1. This is component 1. If I remove this, it will be, this one is one component, this one is another component. Okay, so this is simply a component looks like. So I have to do something optimally. They have given us, so if like what is the cost of component, the maximum edge weight. So this one is maximum, so this will be the cost. So I'm doing a splitting, right? I'm just removing edges. So why not to remove the edge which is having the highest weight, because in that way I can go towards the optimal solution, the minimum possible answer, right? So I will try to remove this edge. Let's try to remove this. I will remove this. Okay, so this part is removed, you can forget this 6. Okay, now I have this component and this is my another component. Now can you tell me cost of this cost is 0. Can you tell me cost of this cost is 2, 3, 4. Which one is maximum? Which one is maximum? 4. 4 is maximum, right? So I will return 4. And okay, I think I told you that 5 will be answer from this 2, but no, 7 will be answer. Why? Because we have given that we have to return the maximum possible answer. Leave the maximum cost among all the components, so we have to return the maximum cost among all components, so 7 will be answer. Okay, so in that case the cost is 0, this cost is 4, so maximum is 4, so I have to minimize this 4. Okay, that's what we have to do. So let's try to take one more example. I think they have provided us. Okay, this one is very simple. Let's try to create one example and try to understand what is given to us, what we can do. So let's try to create 2, 3, 4. So this one will be 4, 6, 7, 8. Okay, tell me if I can I provide this as input? If you are saying yes, then you should again go and read the problem, because this can't be provided. they have told us, right? We have to the input will be connected graph. So this is not connected graph, so we have to connect it. Let's try to connect this way. Okay, let's assign the cost quickly. Let's say 2 4 6 8 3 5 9. Okay, now let's say my k is equal to 3. Nice. So what I can do, so we can have at most 3 components. Yes, so I can have a split like this. So my component 1 will look like this, component 2 will look like this, component 3 will look like this. I can do this, definitely. Yes, I can do this. Or what I can do, I can have this one as a one component, have this one as one component, and this all part is one component. Yes, I can do it, but I will do it optimally. So let's see what I can do. So I will check. Okay, which age is maximum? This one is maximum, right? So I will split this one. I will have it as a component. So let's remove this part. So 8 is single component, and this rest part is another component. Nice. Now what I can do next? So which one is the maximum cost? This one. So I will remove this. So this is my one component, this is my another component, and this is so this was my first, this is second component, this is third component, and I can allow only 3 components because k is equal to 3. So what will be the cost of this? Can you quickly tell me? Okay, which is the maximum weight? 6. Which is the maximum weight in this component? You can forget this. Okay, we have removed this part. Which is the maximum weight inside the component? 5. Which is the maximum weight inside the component? So if no edges are there, so answer will be 0. That is given to us in question. So I hope question is perfectly clear to you now. Now let's try to see how to solve it. So whenever you see a word like connected components and all, just remember it, you have to use DSU. What is DSU? Disjoint sets union. So whenever you see dynamic graph, dial changing graph continuously, or maybe say like components, connected components, something like that, you can, if you hear in the question, just try to solve it using disjoint sets union. So what DSU, I will just quickly remind you. So it will tell you, it will solve a very interesting problem. So if you have 2 components, let's say 1 and 2, and if you pass in some function, so it will tell you, that function will tell you whether this 1 or 2 is part of same component or not. So yes or no, this will tell you these 2 things. Either 1 or 2 is part of same component or not. So if I, like after splitting, if I call for 1 and 2 and I will tell whether this 1 and 2 is part of same component, it will return me yes. Yes they are. And if I, let's say, pass 4 and 8, are they part of same component after splitting? So they will tell me no, they are not. This is separate. So let's see how we can solve it. So they allowed us to remove the edges, but in disjoint set union we can't remove the edges, but we can uh, we can uh, we can just combine the edges, right? We can combine the edges. Okay, so this problem is very interesting, it becomes now, because in disjoint sets union we are not allowed to remove the edges, but we are allowed to add the edges only. So we have to do something so that we can add the edges and we can solve our problem. So I can think it like this. So this problem is going to be very interesting now. So I can think like this. So if I have given something like this too, let's take the previous example, because that was little small to write. 0 1 2 3 4. I will quickly write it here. 0 1 2 3 4 and 4 2 3 6. I think yes, 4236. Nice. So this one is 3. Okay, so what I was telling, yeah. So let's start. So what I can do, so initially I will consider this graph as a fully disconnected graph, fully disconnected. Okay, so I will consider this node, this node, this node, this node, and this node. So this one is fully disconnected graph. How many components are there in this graph? This is whole graph. How many components are there? Can you guys quickly tell me? So if you say yes, 5, so yes, your answer is correct. So one component, two, three, four, 5, because none of them are connected, so we can say yes. Component count is 5. So yeah, let's try to solve it now. So component equal to 5 for now. So I know one thing for sure. I will try to copy this part. Okay, yeah. So if I have sorted this part, so I think 6, then 3, then no, 6, then 4, then 3, then 2. So let's try to sort this. So 1 comma 3 comma 2, what I am sorting, so I am sorting based on the weights, because that is meaning to me. Then 1, 2, 3, then 0, 1, 4, then 3, 4, 6. Okay, so I'm sorting based on the weights. So this is my minimal weight, then increasing. Okay, so yeah, what I need to do next, so I will slightly decrease the size. Nice. So I can see that 1, 2, 3 is 2, and my component count is 5. So what I can do, I can allow at most 2 components, right? So it's given to me that at most 2 components I have, at most 2 components I can have. So currently how many components I have? 5. Is that allowed? No, it's more, yes. So I need to decrease the graph, I need to decrease the number of components. So how I will decrease, I will do it very optimally. I have sorted it now, so I will just do a minimal, I will just I will just do a sacrifice of my minimal weight, so that later part I have a minimal weight possible. Okay, so let's do it. So 1, 2, 3 I will join. Okay, yes. Now uh, okay, now I can join the next part. So how many components I have? I have 4 components. Okay, I can do more. So I here, now I am here. I can join 1 and 2. Okay, I can join 1 and 2. Yes. Next part is 0 to 0 to 1 I can join. So yes, I have joined. How many components I have? So let's undo one thing. Okay, here my components are 4, 1, 2, 3, 4. If I join 1 to 2, my components count will get 3. If I go here, my components count will become 2, and it's given me that I have components of 2. I have given components of 2. I can have at most 2 components. So if I have joined here this part, so my components will become 1, which is allowed, but that will not give me optimal answer. Why? Because I am finding the minimum value. So how that minimum value I can obtain? So I just carefully see that, this part and this part, the component count is 0 and its component count is 4, right? So I know one thing for sure, that if I optimally in sorted order, if I try to do components addition, so you can see that I'm not removing the edges, but what I'm doing, I'm just adding the edges. So if I'm first of all I'm doing this one, then this one, then this one, and this will give me the optimal answer, for that I can directly print and return that okay, this is my answer, because this one is the best answer possible for this component. Okay, yes. So yeah, that is the thing. Let's try to dry run on this as well. If you see, so I will try on here itself. So this one was 9 and this one was 8. Okay, so what I will do, what I will be doing, so I am doing things in sorted order and my case given to me is 3. How many components I am having initially? So there are 8 nodes, so there will be 8 components. I will do optimally, so I will just add this one, my component will become 7, then I will join this one 6, then this one 5 components, then this one 4 components, then this one 3 components, and that is allowed to me, right? Yes. So this is the last thing that I have added, and which was in sorted order. So whatever number is greater than this part now, that is skipped, that is basically skipped in the uh, removing disjoint sets. While I was removing the edges now, so that thing is removed. So the maximum answer of any component will be that node only, that this node 6 only. So I think that thing is clear to you now, because I'm doing things in sorted order. That helps me keep track of the maximum node. I don't have to do anything fancy or anything heavy. I hope you got it. So let's try to write code for it, and please make sure that to solve this problem, because this is very similar problem. If you solve that problem, you will get a lot of confidence. So what I will be doing here is I will just copy paste the initial part, which is of disjoint sets. You must know it, this is prerequisite. If you don't know, so please go watch some video. I will put something in description. So yeah, that's it. So I will just create disjoint set first. I will be telling that okay, I am having n nodes. What's the next thing I have to do? So I can sort the ages array, and what is the parameter that I have to sort? That will be second value. So I have to sort with the weight. So this is 0, then first, then second, so I have to sort with the second index. Okay, and one thing I know for sure that if that is one edge case. So if k equal to n, so if let's say all the components are disconnected initially and my nodes is also n, my maximum allowed components is also n, then I can definitely return 0. Why? I hope you got it. So we have seen here, right? So if I am having, let's say, 2 components or 3 components, let's say, okay, and this all 3 are connected, and I am allowed 3 components, so definitely I have nothing to do. I can just return 0, right? So it's not connected. If I have given this and my maximum allowed component is also 3, so I can remove every edge, right? So this one is, this one is, this one is, I can remove this. My components count will become 3, and 3 is equal to number of nodes. What does that mean? Each component is having 0 cost. Okay, let's try to okay, wait, I'll quickly erase some part so I can write. Okay, so A, B, C, okay, and this weight is 10, this weight is 20, this weight is 30, and I have given k is 3. What I can do, I can have 3 separate components. So I will definitely go into this part, this part, this part. So this cost is 0, this cost is 0, this cost is 0. So what is the maximum among all this 3? 0 only. That's why I'm returning 0 there. Okay, so now what I need to do, I need to go from edges to edges. I will be removing in the sorted order. So for I in range length of edges u comma v comma w equal to edges of I. Okay, Now what I can do, I need to just I need to keep track of my components count equal to how many components I am having initially, n, right? Okay, now if I can union it. Okay, if I can union it u comma v, then I can definitely reduce the component count. But there is one case. What is the case? If component count is greater than k, then only I will be doing this. Otherwise I will be good to go, right? I will just break it. Yes. And what I can return is, I can have one index also. I can keep track of that. So basically that will start from ages -1, and each time I am going inside this if condition, I can have this index as this ages of index of 2. Okay, so we will understand. Let's understand what I have written here. So uvw, I'm just assigning values. Now I'm checking that if my component count is greater than k, if component count is greater than k, then I can make it k. Yes, that is the condition, right? I have to make it equal to k or less than k. So that's why I'm trying to union it. I'm trying to union it so that my component count reduce. I hope you guys understood it now. So why I have written something like this? So let's see, just for an example, there is one more edge case which you guys must know. So tell me how many components are there. 3 components. Okay, tell me how many components are there. 2 components, right? Tell me how many components are there. Tell me. 1 component. Okay, tell me how many components are there now. Yes, there is still 1 component left, but this age is there, right? This age is not getting me any benefit. That's why I'm having a condition here which basically tells me that, so if I'm having some graph like this now, 1 2 3, and this part is joined, so before joining 3 and 2, I'm just checking that does they belong to same component. If they belong to same component, then this part will be returning me false, and if it is returning me false, what does that mean? My component count can't be decreased. So that's why I'm having this condition here, so that I can take that whether actually my component count is decreasing or not. So I will just keeping track of index, the last index that I have removed. After that index, I can definitely that index will be my answer, right? So I'm just returning that value. Let's try to run this and see. Okay, it's running fine. Let's try to submit it. So submit it. Okay, yes, it is working fine. So I hope you guys got it. This is little a tricky problem. If you have solved this problem will become very easy. If you haven't solved this problem, please try to go and solve it. If you want any explanation or any doubt in this problem as well, you can comment down and I will definitely solve it. And thank you very much for watching the video. Thank you guys.